Welcome. I'm going to get into maths and matrices and go as far as I can kind of go without doing scripting. Certainly into C#, which I am not skilled at. I know a bit about Python, but matrices kind of stump me when I get far enough into the nodes. Anyhow, I'm also going to end with a little kind of weird analog rigging project I'm trying to do with closest points that actually allows the bones on a skeleton to scatter and jiggle and do some funky stuff. And even though I'm not a rig, I don't know how to rig. I mean, I can kind of figure it out. I'm trying to find the irregularities and odd things that would happen in that. Anyway, we'll talk about that in the end. A little script and how I kind of thought of closest point as a means to jitter and shake things. So hopefully stick around for that. And we're going to take a look at matrices. It's not too hard. We'll go into here and we'll enlarge here. I actually don't think we need anything for matrices, actually. That'd be fine. As you go into maths, you'll find you have all these wonderful things to use, and I've done a couple of videos on them. But let's take a look at how to get them operating. You've got about 7 that are in there that they allow you to use, and I'm just going to run them through a script to show you how I generated them. I find a 4x4 matrices is probably the best thing because I'm thinking of transformations down in identity matrices, and you'll see that in effect in the end, all these wonderful effects of what's happening when you do things to these and how the data is being changed. I'll get into some other details in the end as well. So basically, build a 4x4 matrices. I've used a gene pool to generate 16 numbers, so they'll fill that. So I can obviously change my matrices anytime I slap through this. It updates. Basically, it's a 4-row, 4-column matrices. I then wanted to go on and I should probably, just for people's benefits, params, pop on a little bifocals. Basically, I wanted to use, construct matrices to deconstruct matrices, which takes it back apart, gives you the rows and data on the numbers in there. Pretty simple. Then I wanted to run through, and of course, being used is the display matrices tool, which is over here, which I'll show you. And what I'd like to do is be able to display matrices and then input that in, and you'll see I've gotten lost a little bit in what matrices do for transformations on the Rhino forum, but that's really where I'm stumped, is what to do once I generate these matrices, because here's the effects of them. Inverting the matrices is going to take it, flip the data this way, so I've brought the matrices in, inverted it, and then shown that as a matrices what's happened, and then I've gone on and transposed the matrices, which it tells you literally what it does, swapping rows and columns and things like that. Then I did the next one, and what I decided was to put on a value list that I could actually choose the rows 1, 2, 3 to actually make the data change as it progresses through swapping rows, swapping columns. So this is a nice little script for you to be playful. I think that's about as far as I want to go with matrices because, like I said, I want to be able to take this and understand that as rotations. Like here's a quick example. You have a cylinder. You have a boundary representation. You close it up and you want to move it 10 units. Well, if you move it 10 units, you pop in an identity matrix, 1's down the diagonal, 0's everywhere else, and you can see there's a multiplication by 10 here. So other things we'll put in cosine, negative sign, and sine, and you'll get into all the transpose matrices that come out of the, let me just close this up, I'm not used to seeing that so much, that you'll see in the transformations. Every single node that you bring in, whether it was a rotate, it's going to give you a transform, and the matrix, I believe the transform matrix will show exactly what that does. So for you to get a rotate, you actually have to use a matrices like this. You bring these back down to 0 and you put them over here, and that's where you're dealing with sines and cosines. And if you remember anything about trigonometry or matrices from high school, you'll figure it out. So I'm getting the information, but then how do I use that information to put in? So I started looking online in the forums, and I got into C# when it dealt with matrices. And as soon as I click on there, I'm going in, I'm like, well, I don't write C#. It looks familiar. It doesn't look like a huge script. I could manage it in Python maybe. Once again, there's another one here that does similar things. And I think at this point, I cut and paste text that wanted to do what I wanted. I don't know how far I'm going to go back into scripting, even though I certainly have been kind of welcomed back into it through Grasshopper for sure. And there's another one here that's a little more complex, and it deals in iterations and kind of flows through and grabs things and outputs your data in this sense of I don't quite understand it fully. Here's a nice example of a nice script that writes a certain level of columns and rows, so you can change that and bring that down. You can take the to value, change it, but these are kind of custom nodes that are made from the math program section, and I would rather do it in this than see. So if I could translate that script into here, I'd start to be able to generate. But once again, I'm generating matrices. I want to be able to pull them in and know what's happening. You can ignore the colors, but that's about it. I mean, every time I meet with an engineer, they're like, "What do you know about matrices?" I'm like, "Oh, well, I remember them, but how can I use them, and how do I get into more and more data as I start to manipulate geometries?" I think it's going to become more and more necessary. That said, let's go back to this little fun script here, which isn't so difficult to figure out. It's a little bone, and I'll show you how I kind of thought. I figured, okay, let's go into the operators and it might be fun to start. This is the next script with addition all the way through subtraction. Well, I never ended up using that. I actually just imported some bones, and I was like, okay, let's structure this well. Let's grab some. I'll show you. Basically, grab a bone up here that connects to this bone and this bone, and I realized, well, I probably need to orient all these around 0, 0, because what I'm getting into, which was a mistake to think this way, but I don't think it's a mistake. You've got to give this up to people that don't know how to do things and weren't trained in a certain system. I'm making robotic arms. I'm thinking rigging figures for animation. But basically, when I move mine, you'll see it just doesn't stay to that point. It's not as convenient as having that oriented point. You actually get these pretty cool jittering or cartilage or bone moving things happening. And that's where I'm most excited to work with. And as an artist, you're going to want to get with other people, programmers, to help you out. But I basically took the data of all these items and I figured, well, let's orient them in other positions. So if I had that, I could move that one up. So even though I have the original geometry, I could look at it in its original. If I look here, I could look at it in its original state, but then I could have it in its move state. I could look at it in its original state. I could have it in its move state, and I could look at it in its original state and have it in its move state. And in doing so, you can see it kind of jostles because I've used closest point like crazy and blowing apart the mesh and some list items, which are probably unnecessary. Like this is unnecessary. I was getting into more data than I wanted, so as I delete that, you'll see it still works fine. I was dealing in multiple points and really getting in the closest point and probably using it a little too excessively. But it allowed for some playful things and actually got into a populating 2D, which is irrelevant when you're actually bringing it down to one count. But it was much more active when I started, and then I kind of got lost in the jittering action of it. But once again, I've started something that if the script works, I could apply it to all the bones and have them jump and jostle and do the full skeleton, which is what my intention is. And what I'm doing is that's kind of a side project to make things exciting for me because humans like to look at humans, and I've got all the I've got all the geometries on here up to the full skeleton if I want to get going on both legs, and it should be fun. Anyhow, that's 8 minutes talking a little bit about bones and I had some fun wiggling things around. I think doing your first kind of, animating your first frog leg, is the beginning of kind of Frankenstein, Dr. Frankenstein. So we'll see where it goes. Thanks for watching. I'm hopeful to keep this interesting and people are still watching. I have a few hundred followers and I don't know. We'll see where this leads. I promised 1,001 scripts and we're at 32. Thanks for watching.